Hello, Algebra 1 students. This is Amber, the math tutor, and we're looking at Lesson 1-9, Reducing Fractions with Factor Trees, Part 2, Canceling Factors in Fractions. So here are the two notes that we're going to be working with for our examples when they come up. If the same factor is on the top and the bottom of a fraction, they cancel. Here's an example of that, 2 times 7 over 3 times 7. So we have two factors up here, two factors down here, and we have the same factor on the top and the bottom, 7. So they're going to cancel. And we'll write that in just a second. After we look at this note, it says this only works for factors. Remember, factors are separated by multiplication signs. This does not work for terms. Terms are separated by addition and subtraction signs. Remember in lesson 1-7 when we were talking about combining like terms, we said terms are separated by addition and subtraction signs. That is represented in this example. We have 2 plus 7, so these are terms, not factors. 3 plus 7 are terms, not factors. So in this first example, we have a factor on the top and the bottom that's the same, they cancel. I'm going to write that right here, the 7s cancel. The 7s cancel. And over here we have 2 plus 7 over 3 plus 7. Nothing cancels. We don't have any factors here that we can cancel. So let's look at these examples, and here's our instructions. Reduce the fraction by expressing each number as a product of primes and then canceling. So let's go through and do factor trees for 10 and 15. So 10 is going to be 2 and 5. 15 is going to be 3 and 5. So 10 on top is going to be 2 times 5 over 3 times 5, and then the 5s cancel. And what are we left with? 2 on top and 3 on bottom. So 2/3. Okay, that's it for number 1. Let's do it again for number 2. We have 40 and 15. So we already know 15 is 3 times 5. What's 40? I usually do 2 and the example, but I want to show you an example without one to show you. You're still going to be able to get the correct answer, even if you don't start with 2 and like 20, for instance, here. So I'm going to start with 4 and 10. Neither of these are prime, so we have to keep going until they're all prime. So 4 becomes 2 times 2, and 10 becomes 2 times 5. So that's what we have for 40. Let's write it on the top there. 2 times 2 times 2 times 5 over, and then 15 we already know is 3 times 5. So the only factors that we have on top and the bottom are the 5s. And that means we have 2 times 2 times 2 is 8 on top and 3 on bottom. And let's do it one more time for number 3. So let's do the factor tree for 18. I'm going to say 2 and 9, and then 3 and 3. And then 30 becomes, I'm going to do 3 and 10, and 2 and 5. For 18, we'll put that as 2 times 3 times 3. 30, 3 times 2 times 5. And what can we cancel here? We have 2s, and one set of 3s can cancel. And we're left with 3 on top and 5 on bottom. And that's it.